My name is Munagala Ramanath, or Ram for short. I'm a software engineer with DataTorrent. And today we'll be talking about how to build your first Apache Apex application. Not everybody may know what Apex is. So I thought I'd start with a very brief introduction of what Apex is. Apex is a platform designed to run on a Hadoop cluster. So it runs on multiple nodes on a network. It's all written in Java, and it's designed to process streaming data as well as batch data. Traditionally, Hadoop applications have used MapReduce, which was intended for processing batch data. So that's data that's at rest, has a fixed location, and the totality of data is already present there. Whereas streaming data is different in the sense that it has no beginning and no end. So an example of a data stream would be data coming from, say, a windmill farm. Each windmill has hundreds of sensors, and data from these sensors is constantly being streamed to some site. And that data needs to be processed as it's coming in. We can't really store it and process it in batch because it doesn't really have an end. So that's what streaming data is, and Apex is a platform that allows you to build applications for processing such data. Okay, so here's a quick outline of the presentation today. We'll talk about the main concepts of an Apex application, and then we'll briefly describe the application we'll build today, called the sorted word count. And then we'll do a hands-on demonstration of how to clone the Apex repository of source code and how to build it. Then we'll do a hands-on demonstration of how to build a new application. Then we'll run the application, and finally do a quick code walkthrough and answer some questions. Okay, here's the main concepts that we'll be talking about. Applications in Apex are built out of operators, and an operator is something that implements the operator interface in Java. So you can think of an operator as a Java process. Each operator has input and output ports that are connected by streams to form a directed acyclic graph. Sometimes people just refer to it as a DAG for short. These input and output ports of an operator don't really have any direct connection to TCP/IP ports. These are just Java classes called input port and output port and default input port and default output port. So it's important to bear that in mind. The base operator class is provided, and it's something that simplifies writing an operator because it gives you empty implementations of all the required methods in the operator interface. Now, within an operator, you'll need to define whatever input and output ports you need using those classes that are already provided by the platform. Default input port, default output port. And finally, you'll need an application class that implements the streaming application interface. So there's only one method to implement, populate DAG, And in that method, what you do is instantiate your operators by calling new, the usual Java way, and then you wire them together, meaning you connect the output port of an upstream operator to the input port of a downstream operator, all the way down the DAG. Apex itself is split into two parts. One is called Apex Core, that's the core platform code. That's in one repository. And there's Apex Malhar, which is a set of pre-built operators. So for many of the common use cases, we've already built many operators, and those are encapsulated in this Malhar library. Okay, so today's application is called the sorted word count, and what it does is it reads files that are dropped into an input directory on HDFS. HDFS is the Hadoop distributed file system. So you drop a text file into the appropriate directory, and the application will pick it up, read it, split it into words, and then do a word count, and then sort the word count pairs by the frequency with which each word occurs, and it will then emit these word frequencies along with the words in sorted order to an output file in the configured output directory. So there's 5 operators involved. Line reader essentially picks up files from the input directory, it monitors the input directory, and then reads any file that's dropped in there, and then splits it into lines and writes out the lines on its output port, which is connected to the input port of the word reader operator. And the word reader splits each incoming line into words using a regular expression and outputs the words on its output port. Window word count computes and emits the word frequencies for all words in the lines processed in the current window. So we have the notion of time-based windows. Typically, these windows are a half a second. And within your operator, there are callback functions provided called begin window and end window. So you don't have to implement these callbacks, but if you do implement them, you can do any sort of bookkeeping work every half second, if that's useful for your application. So in this particular case, we emit the word count per window in this operator. Then there's this file word count operator, which accumulates all the word counts for the current file from all the windows, and it is told when the end of a file has been reached. So when it detects that end of file has been reached, it emits it sorts the list and emits it on its output port. Now that output port is connected to the input port of the word count writer, which then takes that list and outputs it to an output file in the output directory. Okay, so here's a picture of the DAG, the directed acyclic graph, and how these operators are wired together. Line reader emitting lines to word reader, emitting words to window word count, emitting word count pairs to file word count, which then emits the final list, sorted list, to WC writer. Notice that there's also a connection from line reader to file word count, a separate connection. These connections from input to output ports are called streams. So here we have a separate stream called control, and this is the stream that communicates from the line reader to the file word count that the end of a file has been reached. Okay, here's a whole bunch of resources. Apex.apache.org is the main site for Apex. There's a bunch of links there to Google Groups and community and download sections, Twitter links, meetups, webinars, a whole bunch of videos. So a lot of information about Apex is available at these various links. We're also hiring in various roles. So feel free to submit your resume to jobs@datatorrent.com. Finally, there's the Apex Big Data World that's scheduled in Pune, in India, on February 10th, 2017, and in San Jose, April 4th this year. So if you happen to be in Pune or San Jose, please join us at these conferences. This is our premier event for Apache Apex, and it's hosted by DataTorrent. You can also visit the website to learn more. The website is apex.bigdata.com. Oops. So let me see. apexbigdata.com. Okay. Okay, there we go. That's what it is. All right. So we're going to stop the presentation at this point and move on to the hands-on part. Okay, so here I have a virtual machine running on Windows. My laptop is natively running Windows 10, and on it I've installed Oracle's VirtualBox software, and this is what the console looks like for VirtualBox. And I've created a guest operating system using Ubuntu 16. So if I just type lsb release -a, you see it reports the particular version of Ubuntu that I'm running. It's Ubuntu 16.04.1. The code name is Xenial. Now, here I've installed Hadoop 272. And the location I've stored in a shell variable called just H, capital H. And on my system, it's installed at software Hadoop 272. Okay, so I'll explain what I just did in a moment. But to begin with, you should have Java installed. So if you type java-version, it'll show you what version of Java you've got installed. And you should also check the version of Java C, which is the Java compiler, because it's important to have the Java JDK installed, not just the Java runtime. The JDK contains the development tools. So if I type Java C-version, it shows you the version of Java C. So currently, for developing applications on Apex, there's just I just see a question asking if Java is the only option, and the answer is yes. Currently, Java is the only option. We are actively looking at providing a Python API to develop applications. It's actively being investigated, but it's not available yet. Java and JDK is one requirement. Git, which is a version control system, is another one. There's the version that I'm using. Maven, which is MVN, which is the build system, is the next thing you require. And here I'm using Maven version 3.3.9. And I think that should be it. Okay, so there's been a question about whether this is being recorded, and the answer is yes. The whole webinar is being recorded, and we will be sharing a link with you guys later on. Okay, so at this point, let me create a new directory called work, and I'm going to step in there, and we'll do all our work over here. So I have, the first thing we're going to do is to clone the Git repositories. So the URLs for the repositories I've put them into a file that I have locally. You don't really need this file, but it saves me a little bit of typing. So it's a very simple file. Oh, okay, so there's somebody saying they can't see the left bottom of the console. All right, hopefully this is now visible. Okay, so I'm going to source this file. Hang on just one second. Okay, so there's the 3 variables called Apex Core, Apex Malhar, and Apex Examples. So you can just type those values directly if you like. But in this case, I'm going to source that file and then do the clone command. Git clone $apex core. Okay, it takes a few seconds. There's a whole lot of files that it's downloading. It should be done pretty quickly. You can see there it prints out progress. It's now more than 90% done. And we're done. So if I do an ls, you can see there's a new directory called Apex Core. Okay, so now we're going to do the same thing to clone Apex Malhar. Okay, so Apex Malhar is going to take a little bit more time because there's many, many more files. So these files all represent operators for connecting to a number of different external systems. So most common external systems are already supported. Things like Kafka, various JDBC databases, file systems, Amazon S3, and so on and so forth, JMS sources. So from all these variety of sources, you can receive data, process it within your Apex application, and then write data back out to any of these destinations. So input and output operators for most of these common data sources are provided. So while that Git checkout is proceeding, let me show you a couple of additional things. Documentation for various parts of Apex is available at docs.datatorrent.com, and this is what the site looks like. And in here, there's a beginner's guide link on the left, and that's a good place to get started, to get sort of an overview of the Apex landscape, and it gives you a simple way to get introduced to the various parts of Apex. The site apex.apache.org that I mentioned in the resources slide looks like this. So here various current events are listed, the most recent versions of Core and Malhar that have been released, and there's also a community page that shows you the mailing list to join if you want to participate in the Apex community, and so forth. There's also guidelines if you want to contribute to Apex, and so on. Okay, so let's go ahead and see if this... Okay, so it looks like the checkout has finished. There's the two directories. Now I'm going to do the same thing with examples. Now examples is a much smaller repository, so it should finish pretty quickly. Let me show you what it looks like on GitHub. So github.com/datatorrent /examples. And over here, you'll see there's a directory called tutorials. That's where all the examples are, and you can see there's a huge number of examples. So each one is a self-contained example application that you can simply build and run. And they show you how to pull data from JDBC or HDFS or Cassandra, and then do some minimal processing, and then write back out to maybe Kafka or JDBC or ActiveMQ, and so forth. There's a table down there that gives you a brief description of what each application does. All right. So here, that's also completed, and there's the 3 directories. So what we'll do now is let me just for review echo the 3 URLs from where we cloned it. Apex core came from github.com/apache/apex core, and then Apex Malhar is simply Apex Malhar, similar to core, and then Apex examples is github.com DataTorrent examples. Okay, so let's go into Apex core, and here you'll see there's a bunch of files and directories. The Plumb.xml is the maven file that determines how the build takes place. So we're going to build this code base now. And we do that by running the maven command, maven clean install, and then -d skip tests. So clean simply removes some people get a little nervous when they see install because they think you might need root access or super user or admin access to do that. You don't really need that because this install is not installing anything into the system locations. It's only installing artifacts into your own home directory. So in your home directory, there will be a directory called .m2, and that's where all these things go. So you don't need to be root to do this. Okay, so let's run this and see what happens. Okay, so it's printing out some status information as it chugs along. Usually takes about a minute or 2 to finish this build. The Malhar build takes a little bit longer, maybe around 5 minutes, because again, as I said before, there's many more files there that need to be compiled. So let's see, it should be almost done over here. All right, so while this is going on, let me show you here, going to a different console window, and so here I just looked through my history to see how to start the Hadoop daemons. So you have to make sure that once you've downloaded and installed Hadoop, you have to start the daemons. And to do that, Hadoop provides in the sbin directory a script called startdfs .sh. So if I just run that command, it will start the distributed file system daemons. Recall that capital H was just a path to the location where Hadoop was installed on my machine. So under the Hadoop installation directory, you'll find an sbin subdirectory, and under that you'll find the startdfs.sh. So just to refresh our mind, here's what $H looks like. Okay, so once we've done this, there should be some daemons running. You can run the standard Linux there's also a command called JPS, which shows you Java processes that are running in a more compact form. So if you run this, there you go. You see name node, secondary name node, and data node are running. So those need to be running in order for the file system to work. Now we also need Yarn. Yarn is the resource manager for Hadoop, and that's in command number 1116 in my history right here. So I'm going to run that one, bang 1116, and that will start up Yarn. Okay, so it tells you where the log files are going, and if I type JPS, we should see a couple more processes. There we go. We see the resource manager running and the node manager running. Okay, so if these processes are not running when you run JPS, then there's something wrong with your Hadoop installation, and you need to address that first before proceeding further. Now, once these daemons are running, you can also do a sort of a secondary check to make sure that everything is healthy by going to the browser on the node where Hadoop is running, and then you go to localhost port number 50,070, 50070. This is the console for HDFS. Okay. So here you see it's showing you various statistics about memory, and an important thing is here it says safe mode is off. That's important to see. Sometimes you'll see safe mode is on. That means the file system is not really ready for use. It's still being checked, and eventually it'll come out of safe mode and turn off safe mode. Okay, so this is for HDFS. There's also another console for Yarn, and that is the same local host, but port number 8088. So if you go to that port, you will see this sort of a page that shows you various metrics and then what applications are running. So right now it shows no data in this table because there are no applications. But once we start an application, you should see a value in here. Okay, so let's go back to our console. And we see that Apex core has completed, build success. So we'll do the same for Mulhar. So here we are in Mulhar. I'm going to run the exact same maven command, maven clean install d skip tests. The skip test argument is just skipping the unit tests because we really don't need to run the unit tests and they take a long time. So I'm skipping those. All right, so you notice above that it took 1 minute and 41 seconds for Apex core. Building Mulhar will take maybe about 3 to 4 minutes. So while that's going on, let me show you here, when you go into this Yarn console page, if you go into this tools, you'll see a link for local logs. So if you go into local logs, you'll see a lot of log files here. So if something goes wrong, this is a place to go. So here you see the node manager logs, the secondary name node logs, and what's commonly most important is the resource manager log. So yarn dt resource manager demo.log. So if you go look at that file, you can see Yarn getting requests for Hadoop containers from the application and then fulfilling those requests. And then if it runs into any problems, error messages are logged over there. So this is a good debugging thing to be aware of. Now, what about logs from your application? Those show up under this directory called user logs. And here you can see there's a lot of directories. Each directory represents an application. So each application has an ID, and that ID has exactly this form, application underscore, and then a long timestamp underscore, and then a number. So these represent earlier applications that I had run some time back. You can see some are from August, some from September, some from October, and some from earlier this morning. So once you successfully run an application, you can come here and step into the subdirectory for that application to see the logs. So if I look at the application that I ran this morning and go into that subdirectory, you'll see these various further subdirectories saying container something or other. So a container is a Java JVM process. So each Java process running on the cluster will generate its own log files, and those are all stored here. So in our case, we have these 6 operators. Each operator runs in its own container, and you can step into any one of these and then see the log files over here. There'll be a standard error log file, a standard output log file, and a DT log, which is the actual logs printed by the operator code itself. Now, one useful point to remember is the container number 1 is always the application master. That's a special process that orchestrates the operation of the entire DAG. So that one, the files are named slightly differently: appmaster.stderr, appmaster.stodout, and dtlog. So these log files are a very useful resource for troubleshooting when something doesn't work. Okay, so let's check back here and see how this is going. The build is still continuing. So I'm going to wait for that to finish before going to the next step. The next step is going to be here's my work directory. Now I have a simple shell script. It only has one maven command already prepared. Called new project. And there you can see what's in that file. It runs the maven command mvn with a whole lot of arguments. And what these arguments do is they tell maven how to generate a template project, your very first project that has all the necessary directories set up in the right way to start developing Apex applications. So this command is also described in this beginner's guide that I talked about earlier. So if we go here, go to this beginner's guide, in the preliminaries, you'll notice right here, there's that box that contains that maven command. In this case, this is somewhat older, so I'm using the 3.3.0 incubating version. But in our case, we can use a more recent version, and you'll notice I've got version as 3.5.0. And that variable $v is used over here for the archetype version. So archetype is Maven's terminology for using a template to generate a new project. Okay, so here we go. So Apex Malhar has successfully built. So we can now generate a new project. So if we just look at our work directory, this is what it has, the expected contents. Now I will run bash on this new project script. You can run it this way, or you can make the new project script executable and then run it directly. So this should create a new directory called My Apex App containing the Maven project. Okay, so it's successfully completed. And there's the directory that I was talking about, My Apex App. That was the result of running the script. So if I step into that directory, My Apex App, and do an ls, there you see there's a source directory that has the source code and a few other configuration files, and then the pom.xml, which tells Maven how to build the project. So if I do a find on the source directory for any Java files, you'll notice there's already a few Java files there. One is a test file, a unit test file called application test. But there's also a couple of other files, a random number generator and application.java. So this template project that's generated is already contains an application that's ready to go. So you can build this and run it if you wanted to. So what it does is just generate random numbers and then output those random numbers with a hello message to the console. That's all it does. Okay, but we won't bother with this default application. We'll build our sorted word count application. Okay, so as I said, you can build this here if you wanted to by running the exact same maven command that we had over here, which is mvn clean. Now instead of install, I'm going to use package, because I don't need to install this application into the local Maven repository. I just need the application archive file built. And to do that, you just need package. So just to make a quick tangential comment here, if I go to my home directory and then do an ls -l of .m2, you'll see that's the place, .m2. Within that, there's a subdirectory called repository, and that's where all these Maven artifacts are installed when you do the install command. And that directory can get to be fairly large because all the dependent Java libraries for your project get downloaded when you run the maven command and installed in here. So if I do a du command to just look at the size of that directory, du-sh.m2, you'll see it prints 769 megabytes. So it's almost a gigabyte. Okay, so now for this sample project, I don't need to install it. Like I just said, I just need to create the package. So I use the package command and also add the skip tests. Now notice that in this directory, we only had one subdirectory called source, src. After we run this command, there will be another subdirectory called target. And that's where all the build artifacts will be placed. Okay, so let's build it. This should be pretty quick because there's not a whole lot of files to compile. So it finished in about 19 seconds. And there you see the target directory that I was talking about right here. Now if I do an ls -L of target, you'll see there's many subdirectories in there and files within them. But the important thing for us is this APA. So APA stands for Apex Archive. The file. So you can look inside of it using the standard Java file that we will need to launch on the cluster eventually. Okay, so now what I'm going to do is to go in and create the source files for our sorted word count application. To do that, I go into source, Java, com apex my apex app, and here's the two files that we had before. So I've already prepared some source files for our sorted word count just to save some time, and those are available in the examples repository. So inside examples, if you go to tutorials, and within that there's top N words, and within that there's webinar. There's the Java files that we want. There's some 7 or 8 Java files. So we're going to copy those to here. Webinar / start.java, copy. Now if I do an ls-l, you'll see all of those Java files have been copied. Now what I need to do is also copy a configuration file. In resources, there's a directory called metainf, and there you'll see a file called properties.xml. Now, what I'm going to do is copy the XML file from the examples directory. Star.xml, copy it here. So it's copied this one file, properties-sortedwordcount.xml. Okay, so now we're ready to build and run this application. So I go to the top level, and then I run my maven command just as before. Clean package skip test. So this time it's going to compile all those new Java files that we just copied over. Okay, so while that's going on, let's go here. Okay, so we mentioned the input and output directories that this application is going to use, and those are on HDFS. So if I run the HDFS command, temp test is where those directories are located. You'll see there's 2 subdirectories called input dir and output dir. Now if I list the contents of input dir, there should be nothing there, and indeed there is nothing there, and the same with output dir. Okay, so what we'll do is once we run the application, we'll copy over a text file into the input directory and then look for the computed results to show up in the output directory. Now I need to, my text file is actually on the host, so I need to mount the directory from the host, and the command for that is in this mount.sh command that I've created. This is a VirtualBox thing. So if I just do bash mount.sh, it should do the mount, and then if I do an ls on the shared directory, which is where I have it mounted, we see this file called Pride and Prejudice. This is the novel by Jane Austen that I downloaded from the net, from the Gutenberg project, where they have a lot of old novels available for free download. So it's a plain text file. That's the file that we'll be using as our input file. Okay, so let's see if this thing is finished. Yes, it has finished. And if I do an ls-l target /star.apa, you'll see it shows a timestamp of 10:49, which is correct, which is just about a minute ago. So that's the APA file that we'll be launching. So to launch it, what I do is I go into the work directory and use the script called Apex that's located in Apex core. So if I do a find command on Apex core, you'll see there's a bunch of files called Apex, but the one that we're interested in is Apex core engine source main scripts Apex. So I'm going to run that. So it works kind of like a mini shell. So it gives you this prompt saying Apex. It shows you what version it's running and so forth. And at this point, there's a number of commands you can use. If you just type help, it shows you a list of all the commands. But the ones that's important for us is the launch command and list apps. So if I say list apps, it shows you the list of apps that are currently running. And indeed, you can see it shows nothing because there's no apps running. So we'll do a launch command and then give it the path to this APA file. So that's home dt work my Apex app /target. And you can also use wildcards here, so I'm just going to use star.apa because there's only one APA file there. So that should launch it. It takes about a minute for it to launch because there's a lot of work that happens, a whole bunch of jars. Oh, actually, it recognizes the fact that in that APA file, there's multiple applications. The first application is the random number application that I was telling you about called My First Application, but we're not interested in that. The second one is a sorted word count. So it asks you to choose, so I'm going to just type 2 and hit enter. And at this point, it collects together a whole lot of jar files that are needed for that application to run and sends them over to the Hadoop containers to run, and gives you back the application ID. Recall that I told you that the application ID would be this long string, application underscore, and then a timestamp underscore, and then a number. So that ID is important to remember someplace, because if there's troubleshooting, you'll need to use that application ID to look through the various log files. Okay, now here, if I do list apps, it should show me the app, and indeed it does. It tells you when it started, tells you the ID, the name, the state is running, and a bunch of other things. Okay, so our application is now running. If we now go to our Yarn console, which was showing an empty list of applications, and then refresh this page, we should see the application show up here. There we go. We see this application ID here, and it shows the state is running. So Yarn also shows you the application is running. All right, so what we'll do now is we'll go back to this console, and we'll copy over HDFS DFS dash put tilde slash share slash Pride and Prejudice text to slash temp slash test slash input dir. So the put command does the copy to HDFS. So now if I do HDFS DFS ls of that input dir, we should see the file present over there. And indeed it is. You can see it's about 717K bytes. Now let's see if the output dir has the output in it. And indeed it does. So the application has finished processing the file. Notice also that the size of the output file is a lot smaller, which is what we expect because the output file only has the words and their frequencies. So let's look at that file by using the HDFS cat command. Output dir slash oops. Pride and Prejudice.text. But this is going to generate a lot of output, so I'm going to pipe it to head, which will print just the first few lines. Okay, there we go. So the application is successfully run, and you can see the frequencies are sorted in descending order. So the most frequent is the article the, which is what we'd expect since it occurs so frequently in English, and then various prepositions and conjunctions like to and of and so forth. So the application has successfully run and produced the output file that we expect. Let me now show you very quickly what this application word count, the main application file looks like. So if I just edit this file, application word count.java using VI, you'll see, let me widen this window. You'll notice the file is actually pretty small. It just has about 20 lines or so. So we need to specify the name of the application, and here we specify the name as sorted word count using this application annotation, Java annotation. Notice the class implements streaming application, as we mentioned in the initial slide deck. I also create a logger so that I can log information here if necessary. And then here's the populate DAG method that I was telling you about. So we have two sections here where we create the operators by saying dag.addOperator and using the new command to create the line reader, word reader, window word count, and so forth. So the add operator will return the actual operator created with this new as its value. So I assign that to a local variable here. Now I need to give the operator itself a name as a quoted string, and that's the first argument. This is because you can have multiple instances of the same class. So in order to distinguish the individual instances, we have to give it a unique name. Once the operators are created and added to the DAG, we need to create streams which connect the output port of the upstream to the input port of the downstream. So here's the stream, and again the stream needs a name, so I just call it lines, and it's connecting the output port of the line reader to the input port of the word reader, and so on down the line. So that's how applications get created. One last thing. Configuration file. Recall that we went into this meta-inf directory and added this properties-sorted word count.xml. And if we look in there, we'll see that it's an XML file. And here, there's various properties of operators that you can configure. So for example, the word reader needs to know what characters are considered part of a word and what are not part of a word. So it has an internal property called non-word string, which should be a regular expression for matching the parts that separate two words. So here we've used the regular expression that says any punctuation or any white space, one or more occurrences of those things, can be used to separate words. And here's the specification for the input directory that's monitored, /temp/test/input_dir. That specifies the value for dt.application.sortedwordcount.operator.linereader.directory. And then specification for the output directory, and then various memory settings. So memory tends to be an important issue. So there's various fine-grained controls that we provide for configuring memory, limits on memory. Okay, so that's about all I had planned for today. That concludes our presentation for today. I hope you found it useful. If you have any questions, feel free to type them into the questions panel. And in another 30 seconds or so, I will close the session. Okay, so it looks like there's no questions. As I mentioned before, the entire session was recorded, and we'll be sending you links to that recording. Thank you very much for attending, and happy apexing. Goodbye.